Hi everyone, welcome back to the BodyMetrix Pro training tutorials. Today we'll show you how to capture an image or cross-sectional picture using the scan feature. Scanning gives you the ability to target specific areas of interest and examine, quantify, and track both fat and muscle layer thicknesses. It's an excellent tool which validates the effectiveness of diet and exercise and provides tangible proof of change, showing evolution, progress, as well as regression. Scans can be used while in demonstration mode or within an existing client's profile. To start a scan, click on the Scan tab at the top right of your body view screen. You'll notice a scan point drop-down menu underneath the Trends tab where you'll see multiple areas to select from. You can also create your own scan point by selecting Other and then typing in the name of the area. For example, left bicep or right thigh and so forth. This can be useful to compare scans to the left or right sides of the body to see differences in muscle development and fat thickness distribution. In this example, I'll go ahead and select the bicep. Next, apply about a quarter-sized amount of gel to the head of the BodyMetrix device as shown. With the arm in a relaxed position, spread the gel from approximately 1 inch above the peak of the bicep in the center of the muscle down to the elbow, approximately 3 to 4 inches, without pressing the button. You're moving the device up and down to ensure it will glide smoothly on the skin so it doesn't stick or bind. When you're ready to start scanning, go back to your starting point approximately 1 inch above the peak of the bicep at the center of the muscle, press the button, and with the device flush and perpendicular on the skin, slowly drag the device downward in one direction, stopping at the bend in the elbow. The speed you're moving the device is approximately 4 to 5 seconds in most cases. As you do this, you see a cross-sectional picture form on the screen. The left side of the image represents the starting point of your scan above the midpoint on the bicep, and the right side is the end of the scan at the bend of the elbow. In examining this image, we see both white and light blue bands of signal, which represent strong ultrasound reflections or echoes that identify boundaries or interfaces between different tissue types. For example, the fat-muscle interface or the muscle-bone interface. Our primary focus will be on the white bands of signal, and it's important to understand that these bands do not necessarily represent fat, but rather identify changes within the tissue itself. Once we correctly interpret the various bands of signal, we can then determine the fat and muscle layer thicknesses. Starting from the top of the cross-sectional picture, which represents the skin surface, we see a strong white band here at 5 millimeters going from left to right. This signal separates the fat layer from the muscle, which is known as the fat-muscle interface. You can drag a small rectangle from various points on the signal to the top of the image to see different fat thicknesses throughout the scan, shown here in millimeters. What you're also seeing in this image is a region here which represents the first muscle group in the bicep known as the biceps brachii, and the second muscle group here known as the biceps brachialis. The last white band of signal here around 40 millimeters is a reflection off of the humerus bone and represents where the muscle actually meets the top of the bone, or the muscle-bone interface. The distance from the fat-muscle interface signal to the top of the bone gives you the total muscle thickness in millimeters, located here. One of the things that you can do is track these interfaces, which allows you to quantify both fat and muscle layer thicknesses. To do this, click on the Track Interface button, and then using your mouse, place your cursor on the fat-muscle interface signal, positioning it in the center of the signal as much as possible, and click. You can adjust the tracking by setting your own data points by moving your cursor to the desired area and clicking again. Once you're satisfied with the tracking, click the Stop Tracking button. Next, you can track the muscle-bone interface where the muscle meets the top of the bone and adjust as needed. We have now quantified both fat and muscle thickness. The white signal we see within the muscle typically represents intramuscular fat or other tissue structures such as connective tissue or veins, so you can potentially look at the quality of that muscle as well. The contrast slider allows you to adjust the amount of blue signal displayed, and moving it up reduces it. It allows you to see the white signal interfaces more clearly in some cases. The brightness slider adjusts the brightness of the scan image, much like the brightness levels on your television. There is also a grayscale option, which many medical professionals prefer as it closely resembles an X-ray image. Note that there is an option to adjust the scan speed, and the default setting is set here at 3. With speeds 2 and 1, you're dragging the device much slower, which can render a higher resolution scan. However, the default setting speed of 3 should be sufficient. The BodyMetrix system allows you to control the depth of the scans, and the default setting is set at 60 millimeters. Depending on how muscular an individual is, or conversely, how sedentary or obese they are, it may be necessary to adjust the depth accordingly if you're not able to see where the muscle meets the bone or the muscle-bone interface. You can always adjust the depth and immediately repeat the scan to capture and display the tissue. This is especially helpful with obese individuals carrying substantial fat in targeted areas, or for bodybuilders with extremely muscular thighs or biceps. The 60 millimeter default depth setting is generally fine for relatively fit individuals. The intensity slider at the top left of the image page changes the sensitivity of the BodyMetrix device, and higher values can be used to detect deeper structures. The default value of 180 should be suitable in most cases. However, if you're seeing a lot of white regions, and it's possible the intensity is set too high, causing the BodyMetrix signal to saturate. In these situations, you can get better image by reducing the intensity to 160 or lower. Let's repeat the bicep scan with the intensity turned down to 150 to show you the difference. In this scan, the white signal is reduced, making it easy to see the interfaces. With individuals that are sedentary or obese, this can be very useful, particularly with the waist abdominal scan, which we'll cover in the next tutorial. These images can be saved by clicking on the Save Image button and then compared to show changes in fat and muscle thickness. Once the image is saved, select the Compare Images button, which brings up a new window. From the drop-down menu on the left, you can select the scan point and then select the date and time of the image that you're interested in, possibly an initial baseline image of a targeted area. On the right side, select the scan point and date and time of the scan image you want to compare it with. Clearly, you can see tangible proof of changes in both fat and muscle thicknesses. This helps to shift clients' focus away from scale weight, as they can actually see progress, evolution, or regression at their targeted areas, and it validates what they may or may not be doing in terms of diet, exercise, or training. You can also uncheck the Show Tracks box for either image and use your mouse to drag a small rectangle from the fat muscle interface anywhere within the image to the top, which gives you a fat thickness measurement below the image here. And you can also look at muscle thicknesses by dragging a small rectangle from the fat muscle interface to the muscle bone interface, as we do in this case. In the next tutorial, we'll discuss how to perform and interpret a waist scan of the abdomen. Thank you.